Hi everybody, I'm going to make a little video to review for the test on chapter 5. I'm just going to go over how to solve all different types of linear equations. We're just going to work out about 5 examples here, and I'll just make some comments along the way. So if you're looking at this video to help you study for the test, you might want to take out your notebook and take some notes. So let's start with our first example here. Start with a basic one. I don't want red, I want blue. Okay, so our first equation is going to be 17x minus 32 is equal to 19. Now remember, our goal here is always the same thing with linear equations. What we want to do is we want to manipulate this equation until we get the x alone on one side, and that's going to give us our solution. So we're going to think of this as a balanced scale. And whatever I do to one side, I can do to the other, and it will keep the scale balanced. Okay, you know that. We've practiced that a ton. Okay, so the first thing I want to do is I want to isolate this x term. And I'm going to do that by getting rid of this subtracting or negative 32. So I'm going to add 32 to both sides of the equation. Let's see here. The negative 32 and the positive 32 cancel out, leaving me with 17x. Drop your equal sign down. Don't forget your equal sign. 19 plus 32 is 51. Now this says that 17 times x is equal to 51. So to find out what x is, we're going to divide by 17. We want to undo whatever's happening to x. So we're going to divide both sides of this equation by 17. Now here the 17s will cancel out, and I'm left with x is equal to 51 divided by 17 is 3. Okay, so notice every step I take gets me closer and closer to having the x by itself, and every step I take cancels out an operation. Here the subtraction 32 is canceled out by adding 32. Here multiplying by 17 is canceled out by dividing by 17. So I know we're kind of past this point, but I just thought I'd throw this up here so you can take a look at it. Let's do another example. And let's do a different color. Let's do orange. Here we go. So we've got a little more complicated here. 3 parentheses 7x minus 3 minus 14 is equal to 8 parentheses x plus 2. Okay, so when we have a problem like this, we can't add and subtract things from both sides yet. I guess we kind of can, but what we really want to do is we want to get rid of these parentheses. The parentheses are in our way. So when you see parentheses and fractions, those are the first two things that have got to go. Okay, and to get rid of the parentheses, what I have to do here is distribute my 3 and distribute my 8. So let's go ahead and do that. 3 times 7x is 21x. 3 times negative 3 is negative 9. The negative 14, nothing really happened to that. Drop down our equal sign. 8 times x is just 8x. And 8 times positive 2 is positive 16. Okay, now I'm going to go ahead and combine my like terms, and then we have an equation that looks kind of similar to our last example. 21 minus 9 minus 14, 21x. 21x. Well, negative 9 minus 14 is minus 23. Nothing changes on the right side. And now I have an equation that has x's on both sides of the equation. Okay, that's something you run into a lot, and the way to fix that is to just move your x's to one side. So since this is like a balanced scale, I'm just going to take 8 x's off of this side. If I do that, I have to take 8 x's off the other side. And my equation will stay balanced. My scale will stay balanced. My equation will stay equal. 21x minus 8x is 13x minus 23 is equal to, well, these cancel out. And I'm left with, the only thing over here is a 16. Okay, now this is almost exactly like our first problem. So we'll add 23 to both sides. That'll be isolating the x term. So 13x, these cancel out, is equal to 23 plus 16 is 39. Did I do this again? And divide by 13. And the 13s cancel. X is equal to 39 divided by 13, which is 3. We've got another x equals 3, which is funny. I think I did that for almost every question here. I have an obsession with 3, I guess. Let's or with x equals 3 being a solution. No, I'm going to go to a different layer just so I can erase everything. All right, different color, purple. Here we go. Our next example is going to have some fractions in it. We've got 3x over 5 plus x over 2 is equal to 22. All right, now fractions are a lot like parentheses. They need to be dealt with immediately. Now the way we deal with fractions is by multiplying by the least common multiple of the denominators. Now whatever we do, when I say multiply, I mean both sides of this equation. So we're going to multiply this side of the equation, put it in parentheses, times, well, the least common multiple is 10. And if I multiply the left side by 10, I have to multiply the right side by 10. Okay? So I'm going to write every step here. This is going to be 10 over 1 times 3x over 5 plus the product of 10 and x over 2. Now I'm making 10 a fraction so you can see the cross-canceling that's going to happen here. 22 times 10 is 220. That's the whole point of us multiplying by the least common multiple, is that it cancels out the denominators. Here I'm left with 2. Divide the 10 by 5. The 5 down here cancels. Here I'm left with a 5. So this is going to be 2 times 3x, which is 6x, plus 5 times x, which is 5x, and the 220 stays 220. 6x plus 5x is 11x, which is equal to 220. I'm copying everything down. At some point, you're going to start skipping steps, especially this one. But for now, let's just do everything. And then finally, to cancel out this multiplication by 11, I divide both sides by 11. And I'm left with x is equal to 220 divided by 11 is 20. All right, so the key was the first step, multiplying by the least common multiple of the denominators. Okay, let's do another example. And now I can just do that. Let's do another example. Let's stick with purple for fractions. This one's a little bit more complicated. X minus 4 over 3 minus 2x plus 1 over 6 is equal to 5x minus 1 over 2. Now I pulled this one straight from the book, so I don't know what the solution is off the top of my head. But I do know that these are, we've got fractions in our way. Really want to get rid of the fractions. How do we do that? Well, we're going to multiply by the least common multiple of all 3 of these denominators. So I need a least common multiple for 2, 3, and 6. That least common multiple is 6. All right, you can divide 2 into 6, 6 into 6, and 3 into 6. So we're going to multiply both sides of this equation by 6. I'll go ahead and do that over here so we can cross-cancel immediately. All right, now I'm going to write down every step. That means we're going to take the product of 6 and this fraction. That's going to be 6 over 1 times x minus 4 over 3 minus the product of 6 and this fraction. That's going to be 6 over 1 times 2x plus 1 over 6. And this is going to be equal to, well, let's just go ahead and do this right now. We'll cross-cancel the 2, we'll get a 3. But when you have this stuff in a fraction, like in a numerator here, you've got to distribute this 3. So this is going to be 3 times 5x minus 1. Okay, let's go ahead and do our cross-canceling over here. This one is going to cancel. 6 and 3 cross cancel, and I'm left with a 2 here. So that's going to be 2 times x minus 4. Now I know a lot of you can probably say that that's 2x minus 8, but I'm going to just go ahead and write down every step. So 2 times parentheses x minus 4 minus, well, let's see what we have here. We've got that cancels, I'm left with a 1, but this is in parentheses. So I'm actually going to have to distribute this negative sign, okay? That's very important. If you don't distribute this negative sign, you'll get a wrong answer. In fact, I kind of wish I did a different problem where this didn't completely cancel out. That way I'd have something to distribute. That's fine. And this is equal to, let's do all our distribution in one step. So 3 times 5x minus 1. Okay, again, the reason why we multiplied by 6 was to cancel out all of these denominators, which we did. But what do we have in place of fractions? We have parentheses. Let's get rid of that. So we need to distribute the 2 here. That gives us 2 times x is 2x, minus 2 times 4 is minus 8. Distribute your negative sign, so that's going to be minus 2x. It's like a negative 1 here. You can think of that. And negative 1 times positive 1 is minus 1. 3 times 5x, 15x. 3 times negative 1, minus 3. Okay, we can combine like terms here. I see x's and constants on this side. What? Oh, okay, well, that's fine. 2x minus 2x, these cancel out. And just interestingly enough, negative 8 minus 1 is negative 9, and that's equal to 15x minus 3. Okay, my x is on this side. I've got nothing on this side, so I'm just going to keep it here. Add 3 to both sides. The 3's cancel here. Negative 9 plus 3 is negative 6, and this is equal to 15x. Divide by 15 on both sides to cancel out the multiplication by 15. And you get the answer. These cancel. Carry our work up here. Negative 6 divided by 15. Well, 15 doesn't go into negative 6, so we're just going to take this fraction and simplify it, and we'll get negative 2 over 5. If you divide this by 3 and this by 3, you get negative 2/5. And that's it. That's our final answer. Okay, now I'm not going to plug this back in to check my solution because that would be a nightmare, but I'm pretty sure that I did all my steps right. Okay, let's try one more. Finally, we have a simple fractional equation. This time, I've got a variable expression in the denominator. Okay, well, nothing really changes. We've got a fraction. We need to multiply by the denominator. I want you to know that multiplying a fraction by its denominator always cancels out the fraction. So in other cases, we multiplied by numbers. Here, we're multiplying by a variable expression. I'm going to multiply both sides of this equation by x plus 5. If I multiply over here to cancel out the fraction, I've got to multiply over here by the same thing. So multiplying both sides of the equation by x plus 5 cancels this out, which leaves me with 24 is equal to, well, I need to distribute here, 3x plus 15. Subtracting 15 from both sides, almost there. 9 is equal to 3x, divide by 3, and you can see that, again, my favorite, x is equal to 3. Let's see, how are we doing on this video? Let's see how long we were doing. I might just want to, am I even recording? Hope so. All right, let's go ahead and stop it here.